Let's start with something called as unit circle. The basic idea of unit circle is that the radius of the circle is, yes, 1 unit. It can be 1 centimeter, 1 kilometer. It has to be 1 basically. Now, a quick question. I'm sure you guys would have answered it. So what is the point coordinate of this point provided this is a unit circle? This is an important conclusion that we need to understand. Remember, this is 1 unit. The point over here, right? A. What is the length? What is the coordinate? That's the question. What is the coordinate of point A, B, C, and D? Anything? Yes, this would be 1, 0, right? And this will be 0, 1. And what about this? It's to the left, so it's negative, and it's 1 unit away. So this is minus 1, 0, and this is 0, minus 1. So official definition of a unit circle is a circle with radius 1 centered at the origin of the coordinate plane. The additional condition being the following, that this point is at 0, 0. Right? That's the additional condition. Now, the question is, where is it useful? Where can I make use of this? It is useful tool for understanding trigonometric functions because it provides a visual representation of angle measures in radians. What does that mean? You'll understand in time, but it has to do with something with trigonometric functions. That's all you have to take from this particular statement. As a whole, you'll understand it in time. So we'll start off with a small task. How exactly to use unit circle for a trigonometric function? We'll start off with something which we know. We will take up a coordinate, say over here, say this point. So this is A, B, and this thing makes an angle of theta with your positive x-axis. The question is, what is this point? What is A and B in terms of theta? The question is, what is A and B in terms of theta? The clue being this. Any idea? What is this length? What is this length and what is this length? Indirectly, we are asking that. So to help us with this, let me name this as OAB. So in triangle OAB, we have the following diagram. OAB, for example. So this is known, this is theta. What else is known in this diagram? An angle is known. And this is 1 unit, right? So we're looking at OA and OB. How will you find this? Yes, making use of sine theta, which is opposite by hypotenuse. So in this case, AB by 1. So AB is nothing but, the height is nothing but sine of theta. Right? And next up is our cos. Cos theta is adjacent by hypotenuse, which is OA by 1. Therefore, OA is what? Therefore, OA is, yes, cos of theta. Now, according to this information, set of information, what can you tell about the coordinate A and B? Yes, coordinate A and B is nothing but cos theta, comma, sine theta. Does it make sense? Right? Because OA is nothing but here A. Let me change this color. So this is A and the height is B. Right, guys? So we saw that OA is nothing but cos theta. So this is cos theta, and height B, right? B is nothing but your sine theta. So let me kind of change this to AA, and this is nothing but your B. Okay, let me put it across over here. Right? It makes sense. Okay, that's it. So basically you have your coordinates being related to sine theta and cos theta. That's the important conclusion that we can make, and I've written over here. The conclusion that we could make from the previous exercise is that the sine function is defined as the y coordinate, very important, y coordinate of a point on the unit circle. It has to be a unit circle, and the cos function is equal to or defined as x coordinate of a point on the unit circle. When we tell on, it is always on the circumference, not inside, right? Remember, this is inside the circle, this is on the circle, and this is on the circle, and this is outside the circle. Now, after all of this, I have a question for you guys. All this is good enough, but what about a scenario wherein we have angle which is more than 90? If I have angle more than 90, which the circle certainly can take, how will we handle such a situation? So can we extend the idea to angles more than 90 degree? That is, can we relate the coordinates, right? A comma B. Here also I can get A comma B because it's just coordinates. Can I extend that idea to cos theta and being equal to cos theta and sin theta? That's a question that we'll be addressing in the next video. So this is an introduction to unit circle. Unit circle is a circle whose radius is 1 centimeter or 1 kilometer. Basically, it's 1 unit.